This is Chemistry 1 Lightning Round Part 1. For the first question, it asks the formal charge on nitrogen in the nitrate ion is blank. So first you have to know that the nitrate ion is NO3 minus, and the Lewis structure for the nitrate ion is going to be N with 3 oxygens surrounding it, a double bond there, in lone pairs surrounding the oxygen. And to calculate the formal charge is going to be the valence electrons minus the number of bonds plus, I say, the number of dots, but it's just the lone electrons. So for nitrogen, the number of valence electrons nitrogen has is 5, and you do minus the number of bonds on the nitrogen, which as you can see here is 1, 2, 3, 4. And there are no dots, no lone electrons. So that's going to be 0. So if you do 5 minus 4, you're going to get plus 1. So the correct answer is going to be D. For number 2, it says the chloride of which of the following metals should have the greatest lattice energy. So this is a periodic trend, and you have to know that as we go up, the lattice energy increases, and as we go from left to right, the lattice energy increases. So when we look at our question, we see that rubidium is right here, and then above it is potassium, and above potassium is sodium, and above sodium is lithium. So lithium is going to have the greatest lattice energy because it's at the very top, and lattice energy increases as you go up. So the correct answer is going to be B. For 3, it says the hybridizations of iodine and IF3 and IF5 are blank and blank respectively. So the Lewis structure of IF3 is going to be I with 3 fluorines attached to it. And these are going to have the full 8 electrons. And then you're going to have 2 lone pairs surrounding the iodine, and that's for IF3. IF5 Lewis structure is going to be I, and it's going to be surrounded by 5 fluorines. And these are all going to have 8 electrons surrounding them. I'm doing a line because a line symbolizes 2 electrons. And then you're going to have a lone pair of electrons on the I. So, looking at both of these Lewis structures, for IF3, the hybridization of that is going to be sp3d, because there can only be one S, 3 Ps. And then for IF5, it's going to have a hybridization of sp3d2. So the correct answer is going to be C. For number 4, it says an anti-bonding pi orbital contains a maximum of blank electrons. This is going to be 2. For question 5, it says which species below is the sulfide ion? Well, we can eliminate B and C because that's sulfate and sulfite. And then we can eliminate D because that's not sulfide ion. So that only leaves A because sulfide ion is S2-. For 6, it says arrange the following individual bonds in order of decreasing polarity. So when we look at our periodic table, to know if something is more polar than another thing, we look at the distance between the two elements. So hydrogen bonded to another hydrogen is like hydrogen's right here, and if it's bonded to another hydrogen, it's like right next to each other. So that's not going to be as polar as like hydrogen being bonded to carbon. That's more polar than hydrogen bonded to another hydrogen. And then hydrogen bonded to fluorine, fluorine is farther away than carbon. So hydrogen bonded to fluorine is going to be the most polar. And then second to that is going to be hydrogen bonded to carbon. And then the one that has the lowest polarity is going to be hydrogen bonded to hydrogen. So the correct answer for this one is going to be option A. For 7, it says the Lewis structure of H2N2 shows what? So the Lewis structure of H2N2 is going to be N double bonded to N with hydrogens coming off of each of the nitrogens, and there's going to be one lone pair on each of the nitrogens. So for this, the correct answer is going to be C because each nitrogen has one non-binding electron bond, which is shown right there and right there. For question 8, it says the hybridization of AS and AsF5 is best described as what? So we have to draw the Lewis structure to determine this. So AS is the middle, and then there are 5 fluorines coming off of the AS, and they all have 8 electrons, so they're all full. And so when we look at this, the hybridization is going to be sp3d, since there are 1, 2, 3, 4, 5. There's 5 bonds. So S has 1, P has 3, and then the D is going to have 1 to equal the 5 bonds that are connected to AS. So the correct answer for this one is going to be A. For 9, it says the molecular geometry of BCl3 molecule is blank, and this molecule is blank. So for this, we have to write the Lewis structure of BCl3. So B is going to be the central atom, and there's 3 Cl's attached to it. They're all going to have 8 electrons. So when we look at this, there are when we look at this Lewis structure, we see that it has no lone pairs, and it's going to have the trigonal planar shape. And since the chlorines are surrounding the B and there's not a different element, that's an indication that it's going to be nonpolar, and there's no lone pairs, so that's also an indication that it's going to be nonpolar. So it's going to be trigonal planar, and it's going to be nonpolar. So the correct answer is going to be A. For 10, it says the concept of resonance describes molecular structure blank. So when we look at these answer choices, we see option A, which has no suitable single Lewis structure. That sounds pretty good because resonance shows multiple Lewis structures for a formula. B, which have several different geometrical arrangements. That's not right because we're not changing the geometry of them. C is which have electron resonating. No. D, which are formed from hybridized orbitals. No. So the only answer choice that is correct is A. For 11, it says which compound has the largest lattice energy. So as talked about previously, lattice energy increases as you go up the periodic table, and as you go from left to right, it increases. So when we look at our answer choices, we can first start with B, which is calcium and sulfur. Calcium's right here and sulfur's right here. We look at A, Mg's above calcium, and then oxygen is above sulfur. So we can get rid of B. And then when we look at CSI, that's not going to have the largest lattice energy. And NaF, Na is right here, and fluorine is right there. Well, we can see that it's not going to be as great as the MgO, so we can get rid of that, and our correct answer would be A. For 12, it says the molecular geometry of the CHF3 molecule is blank and the molecule is blank. So we have to write the Lewis structure for this. So carbon is going to be in the center, and then hydrogen is going to be surrounding it, fluorine is going to be surrounding it, another fluorine, and a third fluorine. Fluorine is going to have 8 electrons surrounding them, and hydrogen only has that one bond because hydrogen is like that. And then from looking at this, we have 4 bonds, so that's like an indication, and there's no lone pairs, so that tells us that it's going to be tetrahedral. And in determining whether it's polar or nonpolar, if we look at this, we see that there's no lone pairs, so that's an indication that it could be nonpolar. But when we look at this, there are 3 fluorines, and then there's a hydrogen, which is different than the 3 fluorines, which tells us that this is going to be polar. So the correct answer is going to be B. For 13, it says a molecular orbital can accommodate a maximum of blank electrons. So the correct answer for this is going to be 2. For 14, it says there are blank sigma and blank pi bonds in HCCH molecule. So we have to draw the structure for this. So there's 2 carbons, and this is how it's going to be drawn. So there is a triple bond between the 2 carbons, and then there's a single bond between the carbon and the hydrogen and the other carbon and the hydrogen. So when we look at this, a single bond has 1 sigma. A double bond has 1 pi and 1 sigma. A triple bond has 2 pi and 1 sigma. So we can tell by looking at this that this is going to be a sigma. There's 1 sigma here, and there's another sigma there. So that means we're going to have 3 sigmas. We're definitely going to have that. And then there's these 2 bonds here, which have to be 2 pi bonds. So there's 3 sigma and there's 2 pi bonds. So the correct answer is going to be A. For 15, it says a molecular formula always indicates A, how many atoms of each element are in a molecule, B, the simplest whole number ratio of different atoms of each element in a compound, C, which atoms are attached to which in a molecule, or D, the isotope of each element in a compound? Well, the only option that is correct would be A, how many atoms of each element are in a molecule.